In 18a, we have a log equation. So let's use the log property where we bring down that exponent in front. So let's do that. So let's say we have 3 log base 2 of x equals 6. Divide both sides by 3, and we have log base 2 of x is equal to 2. And now let's put this in exponent form. So we have 2 to the exponent 2 is equal to x, or x equals 4. Okay, in B, we'll use the log property that multiplies these two. So we're going to condense this log expression. So we have log base 2 of 4x times x equals 3, or log base 2 of 4x squared is equal to 3. Let's put this in exponent form. So we have 2 cubed is equal to 4x squared. 4x squared is equal to 8. Divide by 2, and we have x squared is equal to 2, or x is equal to plus or minus the square root of 2. Now, remember that the domain of log is x greater than 0, positive numbers. So we're going to have to reject the negative square root 2. So we have only x equal positive square root 2. And this one, the negative gets rejected. In 19, we're expanding this expression. So let's do this in one step. We're going to immediately bring down that 3 and bring down the 5. And for the denominator, we subtract minus 2 ln b. Let's remember that ln e is 1. Okay, so we have 3 ln a plus 1 minus 2 ln b. In 20, we have an exponent equation. We want to solve for t. So in this case, we could put both sides in terms of base 2, because 32 is a power of 2, and so is 16. 32 is 2 to the 5th, and 16 is 2 to the 4th. So here we have 2 to the 5t on the left, and on the right we have 2 to the multiplying through by 4, 4t minus 8. And now we can just put the two exponents next equal to one another. 5t is equal to 4t minus 8. Subtract 4t, and we have from both sides, and we have t is equal to negative 8. In 21, we again have an exponent equation, but we can't put both sides in terms of the same base, so we're just going to log both sides. So on the left we have ln 3 plus, I'll bring down the x plus 1 right away, x plus 1 ln 4 equal x ln 7. Okay, let's multiply through here, through the parentheses. So here we have x ln 4 plus ln 4. We want the x's on one side, so let's subtract this, bring it to the other side. So on the left we still have ln 3 plus ln 4 equal x ln 7 minus x ln 4. Now gather together these x terms by factoring out the x. And finally divide by what's multiplying the x. In 22, we want to find symmetries. So let's first look at y-axis. Y-axis symmetry, we replace x with minus x. So let's do that. So here we have y to the fourth minus x plus y squared minus x is equal to negative x to the fifth. So if we simplify this, we have minus y to the fourth minus y squared x is equal to negative x to the fifth. So if we multiply both sides by negative 1, we will get the same as the original. This is the same. Multiplied by negative 1, we have y to the fourth plus y squared x is equal to x to the fifth. So we do have y-axis symmetry. Let's check x-axis. And here we're replacing y with minus y. So we have minus y to the fourth x plus minus y squared x equal x to the fifth. Now because of these even exponents, we get y to the fourth x plus y squared x equal x to the fifth. So we do have x-axis symmetry. Now for origin symmetry, we replace x with minus x and y with minus y. So let's do that. So here we get y to the fourth because of that even exponent. And here I'm going to put this negative in front. And here we have y squared, and I'll put that negative in front. And here we have minus x to the fifth. Multiplying both sides by negative 1. We get the same thing back. So we have all symmetries. Y-axis symmetry, x-axis symmetry, and origin symmetry, all three. 23 says that f is a one-to-one function. That is, f has an inverse, and we have f inverse of 3 equals 7. Find f of 7, and find f of f inverse of 5. So let's do a little diagram and say what this means. F inverse of 3 is equal to 7. So here if we have f, and here we have f inverse, we have a f inverse takes 3 over to 7. So that means that f takes 7 to 3. So f of 7 is equal to 3. Now, f of f inverse of 5, well, that's just equal to 5. If we do a function, if we do, say, an inverse followed by the function, we get the number back.